Hello, everyone. My name is Mario, and I work as a data scientist here at Seven Learnings. And today I would like to talk about navigating the online marketplace and overcoming some of the challenges related to multi-channel retailing. And this is always in the context of pricing and automated pricing optimization. Before I get started, I would just like to thank Minubo for having us again. It's the third year in a row that we present, and it's always been a very cool and pleasurable experience. All right, so let's jump into it. The graph that you see on your left shows the online retail sales in the US from 1992 to last year. And as you can see that as you can see, there's been a steady increase in sales, so steady growth in this industry, especially during the COVID pandemic, where the growth was almost exponential. And as with any industry, there's also, of course, some challenges associated with this rapid growth. And I would like to talk about some of them in this presentation. The first that comes to mind is the high return rate, which characterizes the online retail business. And when I say high, I mean also when compared to offline retailers, and I will get to that in a second. Also, another issue is inventory management and how that is influenced by pricing. But also, these two last points are a bit more related to from a data-driven analysis, or from a machine learning perspective. How do we handle different customer behavior or cost structures based on the country or the platform where the retailers sell their products, and how do we figure out the right number of price channels? So on your left, there is a summary of the return rates based on countries or markets from a client of ours. So this is actual data which is sourced from our case study, and here the business we're talking about is an online retailer in the fashion industry. And you can see that there is a significant deviation in the return rates when we're comparing, for example, Switzerland or Austria with Spain or Italy. So in Switzerland, there's a 56% return rate for this business when people buy stuff there. And in Spain, there's only a 27% return rate. So naturally, the question arises from a data-driven perspective: should we have different prices for the same products across these markets? And the answer is yes, we should have different prices. So we shouldn't treat everything as if it were just one giant market and just disregard the consumer behavior by country, because this wouldn't be very wise. And you can just see from the data why that is. Also, there is an implicit relationship between the price of a product and its return rate. And also another reason is that different countries may have different currencies or just different cost structures or logistic costs. And these, of course, need to be taken into account by our models in order to properly optimize the prices by country. And the same logic applies when it comes to platform differentiation. So platform in this case is, I just mean the websites where this client of ours in this case study, where they sell their products. And here I am only showing the data for the German market, and I'm showing three different platforms: About You, Zalando, and Amazon. So again, we're talking about the return rate, and you can see that, for example, in Amazon there's a 22% return rate, whereas in About You there's a 61% return rate. So there's a difference of almost 40% within the same country, but they're just two two different platforms. So this is why also when it comes to platforms, it's very important to differentiate between these platforms for reasons that I've also listed. And one of them, apart from the return rate, is just the perception or the price sensitivity of the consumer towards the platform is different. So it varies across platforms, and also platforms, a lot of the times they just have different logistic costs, or the business applies different marketing strategies on each of them. And so then the final question would be, in this context, how do we set the right number of pricing channels? And there is, by default, it's not like there is a rule of thumb, but usually it would be the Cartesian product between the number of markets and the number of channels per market. So this product would then be the final number of pricing channels that we have internally for this client. However, the final decision, as I wrote here, is based on data analysis. So it can happen that some markets are very insignificant. They could have like only a few sales, or some platforms that could have like very, very few sales, and it's not worth the effort to also apply optimization there. And in that case, we could lump this very small market together with another similar market. For example, if two markets or channels, they have a very similar behavior in terms of return rate or logistic costs, they are not very easily differentiable, then it would make sense to treat them as one market. But as I said, there is so for every case we look at the data as well before making a final decision. So as I mentioned in the beginning, online retail usually has a higher return rate compared to regular offline shops. And what this means, for example, if you have a return rate of 50%, if you sell 10 products today, in a few weeks, you will probably have 5 of them returned. And of course, this is a pain point, because it means that you're going to have to pay again, in most or in a lot of cases, the inbound cost for these returned products. And sometimes they could be damaged goods which are returned, and also you would have to repackage them. So this is not ideal, and this is why it's very it's very important to correctly predict the return rate, because it plays a huge role in finding the optimal price as well, and optimizing profit and revenue in the end. As I mentioned earlier, there's this dependence, of course, between the price of the product and how many times it is returned. Usually, cheap products are not returned as often as more expensive ones. And in order to find the optimal price, we need to consider this, and also the inbound and outbound costs, which are associated with the shipping of these products, in order to find the optimal margin. And yes, so inventory management is another really interesting topic, and usually for retailers, especially when we talk about seasonal products, their goal would be to sell all of these seasonal products by the end of the season, normally, but they do not want to sell these products too early, because they may be losing some profit at a later stage of the season. And on the other hand, they also don't want to have leftover stock at the end of the season, because that's very hard then in the end to get rid of. So it's like two difficult problems. One is too early sellout, and the other one, which is the opposite, is overstock at the end of the season. But sometimes it could happen that for a very requested product, the retailer would like to sell it. However, it takes a long time until the stock is replenished when they order something which is in high demand. And of course, retailers have also limited stock capacities. And so at 7 Learnings, we have developed some rules. For example, the stock reach rule in order to try to handle these problems which I mentioned before. So the early sellout or the overstock, because here at 7-Eleven by default, when we optimize, we do an optimization with a time window of 2 weeks. So we try to optimize the prices in the next 2 weeks. And this is a deliberate choice, obviously, because for longer periods, predictions tend to be less accurate, but this is a different topic. So the default horizon is 2 weeks. And given that the seasons last longer than 2 weeks, obviously seasons could last 2 to 3 months. We developed the stock reach rule, which in principle has the effect of increasing the prices of some products in order to prevent too early sellout. So it tries to maximize, let's say, the long-term profit. And another approach would be to manage this inventory problem using the seasonal profit rule. And so the basic idea is that when we look at seasonal profit with regard to this short-term profit of 2 weeks, which is the default window, often the price of a product which maximizes the profit across the entire season is slightly higher than this profit maximizing price for 2 weeks. And so we can apply the seasonal profit rule in order to prevent too cheap prices, let's say, which could be profit maximizing in the short term. And we sacrifice this short-term profit for the long-term profit for the seasonal profit, which usually means slightly higher prices for these products to find that sweet spot between not selling too much, but also not selling at a too low price. Yes, and here in this slide, I would just like to briefly talk about the highly competitive environment on Amazon for sellers. So in our tool, we give businesses the opportunity to have different steering strategies for different channels. So, for example, you can see here I listed two channels. One is Amazon and one is Zalando. And for both of these channels, the client can choose to steer differently the prices. For example, they could go for profit maximization for Amazon, and then they could go for revenue maximization for Zalando, depending on the demand on each channel. Also, in the case of Amazon, it's an especially competitive environment because sellers often fight for the buy box. And we also, because of this, we give our clients the opportunity to choose the buy box winning price. Even though it might translate into lower margins, they can still decide to go not with our optimizer's first choice, but just have this buy box winning price in case they want to compete with other sellers. Plus, there's also an opportunity to do some price crawling and to include the prices of the competitors in the decision making of the client. Yes, and something maybe to close on a closing note. We're also doing for this client an optimization of the marketing strategy. So we're not just optimizing prices. So we're not just doing, optimization on the price dimension. So we're not just trying to find the best price, but also we're trying to find the best marketing option for this client. So we're trying to optimize on both of these dimensions. And as I wrote here, we're choosing both the best price and the best marketing option to optimize the profit and revenue. And usually, in order to do this, we would need some kind of third-party API to retrieve the traffic data and the clicks data and the marketing cost data for our client, and then we can integrate it in our backend, so we can regard the marketing cost and what kind of marketing strategies and the history of the marketing strategy. So how efficient it was, and then we can come up with an optimization both for the price and for the marketing option or the marketing strategy. And we do this in this case using Amazon Ads API, but we also support Google Analytics API or whatever API that the client can provide the data with. And just like to illustrate very briefly the effect of this marketing optimization on top of pricing optimization. So in the first scenario, you can see that there is no marketing optimization, just price. And maybe we can decide that 20 euros for this product is the best price. But if we also include the marketing dimension, by keeping everything as it was earlier, just adding this additional information, it could happen that the optimal price is not 20 euros anymore, but in this case, for example, it could be 15 euros, and with this particular marketing option. So all I'm trying to say here is that by adding more dimensions and more information, in the end, we'll just be able to have a more accurate optimization for the client. And yes, so this is pretty much what I wanted to talk about in this presentation. And thank you, everyone, for your attention.